Dear friends and followers, welcome back to my channel and lovely greetings from the AMST building in Ranshofen, Austria. In today's video, I'll address a topic that many of us pilots dread: spatial disorientation. We'll discuss the dangers of spatial disorientation, how to prevent it and recover once you've gotten your aircraft in an upstate state, and what training devices and procedures are developed here at AMST. So let's get started.
Shuttle 7011 Heavy at Romeo, get rid of traffic from the right.
When pilots hear spatial disorientation, they think back to their human performance and limitation lectures at flight school. Now, to say the least, it was all very theoretical, but I want to show you how AMST and their simulators put theory into practice. Okay, we first have to understand what spatial disorientation is. Now let's briefly rewind the clocks to the time of World War I. Flights during that time required a clear view of the sky and ground. Night flights were very uncommon as the visual references were essential to keep the aircraft straight and level and at a constant altitude. So hiding in the clouds would have very likely gotten you killed during World War I dogfights, because once you entered the clouds, you had no idea if you were upside down, going too slow or too low. And pilots relied entirely on their visual perception and personal feelings, which sadly led to many fatal crashes. This all changed with the introduction of flight instruments. Now initially you had 3 gauges. One for the airspeed, one for the altimeter, and one, more importantly, for the attitude shown by the artificial horizon. Why is attitude so important? It gives a visual view of what is up and what is down, and if you're turning left or right. It allows the pilot to visualize motion, attitude, and position relative to the horizon without seeing the actual horizon. Now, the artificial horizon was the absolute game changer in regards to flying into clouds. In today's aircraft, we have very sophisticated visualization instruments that support situational awareness. Now, accompanied by an autopilot and navigational equipment, flying has significantly become safer. Unfortunately though, there are still accidents related to pilots who tend to ignore the instruments or get distracted and fly based on their perception. So the goal of SD training is to learn to overcome what your body is sensing, such as the leans, the Coriolis effect, or the pitch up sensation, and to only trust your instruments at all times. But how do you get spatially disorientated? Now, a simple exercise you can try at home is by holding a baseball bat or a golf club upright from the ground, closing your eyes and running 10 circles around it. Now, once done, try and run in a straight line. It's somewhat impossible because your vestibular system in your ear, responsible for sensing your motion, head position, and spatial disorientation, is literally off balance. Your vestibular or balance system is still under the impression that you are going around in circles and initially struggles to keep you straight and level. This is one way to become spatially disorientated. Another would be visual illusions that can lead to spatial disorientation. For example, if you come in for a landing at night, which of the 2 runways do you think is wider? None, they are both the same width. This is known as the ponzo illusion and can really ruin your day if you're coming in at an unknown airport because you're either way too high or way too low because you have no other visual references to judge the width, the length, or your position relative to the runway. But more on that in a minute. So the simulator you see behind me, with which I'll be taking a flight in a few seconds, is the AirFox ASD, the Advanced Spatial Disorientation Trainer. It looks like any other full flight simulator, but this one has an edge to it. This simulator also rotates around its yaw axis and was specifically built by AMST to demonstrate SD to pilots. Now, standard motion-based flight simulators only yaw to a certain degree, but this one is different. So remember the example I just mentioned of running around a stick. This is one of the examples what the simulator will do for me. Now in flight, this corresponds to the recovery of an aircraft after a prolonged spin. Now the spinning is the running around a stick and flying in straight and level is difficult as walking in a straight line. Now, without instruments, flying straight would be impossible. Now, the instructor can, of course, put me in many more situations where my feeling and the actual attitude disagree. For example, the simulator can give me the body sensation of leaning to the right, but my instruments indicate I'm in a left turn. Now, this is where the two inputs sort of disagree with each other, and this is the classic leans illusion and the most common SD for many instrument pilots. And that's the primary purpose of this advanced spatial disorientation simulator, messing with your vestibular system, that your body senses something completely different to what your instruments are showing. From the control station, the instructor can see my window view, my instruments, and most importantly, my face and reaction in case I get disorientated or uncomfortable, and then he can immediately stop the sim. And communication is established via an intercom system. But enough of the talking. Now it's time to experience spatial disorientation myself in the simulator. So we initially took off from runway 34 on the Greek island of Zakynthos, and Christian gave me a few minutes to do some air work to get used to the plane, which was a generously powered Pilatus PC-7. He then let me climb to 21,000 feet and gave me clear instructions on how to bring the aircraft in a prolonged spin. Now this is better known as the graveyard spin, but hear for yourself.
Start the spin, go to idle power, nose up to pitch of 25 degrees. When the stall warning comes, apply full right rudder and go into a stable spin and recover on my mark.
Roger.
You're authorized to enter the spin now.
Okay, 3, 2, 1, go. .25 degrees pitch. Alright, full right rudder. Aye.
So do you feel like spinning?
I feel a little bit like spinning, yeah.
Okay. Continue the spin, like I said, maintain spinning until I clear you to recover.
Roger. Oh.
Okay.
Holy cow.
Do you still feel like spinning? If you
Not anymore now, now it's fine.
Okay.
Yeah.
Okay, we still have a way to go, so can you just quickly look up to the roof of the cabin,
Okay.
please?
Whoa! Whoa! That, wow.
Okay. Prepare to recover, stick neutral.
Yeah.
Full left pedal
Okay.
to stop the spin.
Let go of the
Recover.
pedal. Left rudder.
Wings level,
Yeah.
recover.
Ah.
And set
And some
cruise power.
Roger.
How do you feel?
Yeah, a little overwhelmed because I still have that turning motion, but now it's stopped. Now I'm fine. Flying
Okay.
level, straight level is okay. But that tilting my head, that was the worst experience. Not good at all. Okay, good.
Do you think you would be able to recover the aircraft inside clouds from a spin without instruments?
No, there's no way. There's absolutely no way. You would have to have your instruments to recover from the spin in the clouds. As we briefed beforehand, always trust your instruments, no matter what your body senses.
Runway 16, you are cleared to land.
Roger, clear to land.
So what's your impression visually, if you just judge it visually?
Visually, it looks like the runway is really, really long,
Okay.
and I am, at the moment I think I'm on par.
Okay.
Yeah.
So I will not change the width of the runway. How does that change
Okay,
it?
now it looks I'm way too low.
Okay.
I'm already too low. Yeah.
How does this now change?
Also, that I'm slightly low.
Yeah.
And yeah, that the runway is really long.
So what I changed initially was the width of the runway.
Yeah.
And then the second one was the slope of the runway. The
Yeah.
upslope approaching an upslope runway always gives you the impression of being high because you're looking top down onto the runway almost, because the angle of the runway adds to your runway perspective. While the width of the runway, like you said, a narrow runway looks very long. An upslope runway also looks very long, so it has the same effect. Please overfly the runway at 50 feet above the threshold, and I will change it back to narrow. And please give me your comment on the speed and height perspective. Okay, changing the runway width.
Okay, much faster, much higher.
I'm changing back to wide.
Much slower and much lower. Yeah.
Okay, we will quickly go to nighttime.
Oh boy.
Go around.
Go around, okay. On flaps, positive rate. Gear up. Oh, whoa. Ah. Wow, that was quite the pitch up.
So what happened?
Somehow intuitively just extended my arm, pitching downwards.
Exactly.
Okay.
So this is also clearly visible. You almost went into a straight and level flight.
No way.
Fortunately, you were on a very steep climb out because it's a powerful aircraft.
Yeah.
Like 20 degrees nose up. If you had only 10 or 12 degrees nose up and would have pushed like this, you would have gone into a negative pitch.
Okay.
Just based on this sensation of pitching up when we got to full power and clean configuration.
Understood.
Wow, what a thrilling ride that was. I'm still completely mind blown by how my body sensed something completely different to what my instruments were showing. It's such an off-putting sensation because you want to trust your gut feeling, sensing that I have to bank to the left, but the correct input is actually to the right. So to overcome your instincts is really hard. I've never experienced anything like this in any simulator I've been in before. And the worst idea was to tilt my head backwards during the spin. This induced a nasty Coriolis effect. I do not recommend to do that. There are many more illusions that the guys here from AMST can demonstrate with their AirFox ASD simulator, but we do not have the time to show all of them in this video. But for what I have experienced today was outstanding, and yet again is a testament that our human body has limits. There is a reason why the subject is called Human Performance and Limitations. Now, in my opinion, many pilots overestimate their limits and tend to push them. As a VFR pilot, you might have flown through some clouds before, although you shouldn't have. And like in this video right here, most gliders don't have artificial horizons for a reason, because they are supposed to be flown in VMC. Please don't get cocky. Only because it worked once doesn't mean it will work every time. If you think your limit is here, in actual fact your threshold is here. So anything in between here was just pure luck. I highly recommend that every pilot, maybe a glider, general aviation, executive or airline pilot, should do a spatial disorientation training on a regular basis. Even if it's on private terms, try it out and learn. It's a training tool, not a simulator to make you sick. I hate to admit it, but the upset recovery training we are required to fly every 3 years in our full flight simulators is nothing to what I have experienced today. With that in mind, the spatial disorientation training has been incredible, and a bottom line for all pilots and potential pilots is to trust your instruments. They never lie, but your sensory inputs can. If you think you're upside down and your instruments say you're straight and level, you are straight and level. Besides SD awareness, it is of course important to have the appropriate authorization, licenses and currency. Do not fly on instruments when you're not qualified. If you want to know more about AMST, the simulator I've flown today, or the spatial disorientation training, you find the links in the description box below. The next thing I want to try here out at AMST is their centrifuge and the hyperbaric oxygen chamber. I cannot wait. And here's your checklist for today. Subscribe to my channel, check. Activate the notification bell, check. Follow my Instagram account, check. And perform a touch and go at my website, check. And don't forget, A good pilot is always learning. Wishing you all the best, your Captain Joe.